Hi, I'm Yasit Sandaruan. So today lesson is grade 10 lesson 2, that is motion in a straight line. Okay, this is a physics lesson. As this is since this is a physics lesson, there are some you should know some mathematical background. You should be aware of some mathematical theorems to do some exercises in this lesson. Okay, so before I move into the lesson, I would like to briefly summarize one theorem, that is Pythagoras theorem. Now you should know the Pythagoras theorem, but if anyone uh, has not learned that Pythagoras theorem yet, okay, I would like to describe in brief manner in this session. Okay, so, if you know the Pythagoras theorem, if you are well aware of the Pythagoras theorem, you can skip the video. Uh, but if you do not know, let's see. Okay. So, it is described, or it is it explains, or it is described to a right angle triangle. That means this type of triangle. There is the right angle, so this is a right angle triangle. So this is hypotenuse. Okay, hypotenuse. Okay, we call that hypotenuse, which uh, lies in front of the right angle. Okay, always it is hypotenuse. What Pythagoras theorem says, if we call this A, B, C, it says always the length of this hypotenuse and its square, okay, length of this hypotenuse multiplied by the length of this hypotenuse. That means the length of CA multiplied by the length of CA. Okay, so I can write this one as what? CA square. Okay, CA square. CA square means CA multiplied by CA. Okay, CA square equal to CB square plus BA square. The length, let's say the length of this CB is Y, length of the BA is Z, length of the side CA is X. Okay, so now I can write the Pythagoras theorem as X square equal to CB, that means Y square plus Z square. Okay, Z square. Okay, let's say this is 3. The length of the CB side is 3. The length of AB side is 4. Now I can find the hypotenuse. Okay, how? According to the Pythagoras theorem, it says hypotenuse square, that means X square, equal to this side length square, that means 4 square, plus this side length square. Okay, so that is 16, that is 9, that will give us 25. Okay, but I need X, not X square, I need what? I need X. The length of hypotenuse is X, not X square, so I need X. to get the x, I can write this as 5 square. 25 means 5 square. Okay. Then I can consider square root of this. I can consider the square root of this one. As I consider the square root of this side, I should consider the square root of this side as well. Okay. Okay. Let's see. There's a number code. There's 5. You add number 2 and add minus 2. What the answer? 5 plus 2 means 7. 7 minus 2 means 5. Okay. So positive and negative means two opposite mathematical actions. Okay. Two opposite mathematical actions. So, and also the magnitude is same, because of that it is cancelled. We get the original number. Likewise, if we do two opposite mathematical actions, multiply and divide. Okay, you multiply by 2 and divide by 2. Two opposite mathematical actions, mathematical operations, two opposite mathematical operations, and the magnitude is same. So what will the answer? The original one will be the answer. 5. Why? 5 into 2 means 10. 10 divided by 2, again it comes 5. So that means this 2 and this 2 is cancelled. So if you do something, if you do two mathematical operations to any number which has same magnitude, it cancels and we can resolve the same number. We can resolve the same number here. Okay, we perform two opposite mathematical operations. So because of that we took the original number. So we here perform two opposite mathematical operations with same magnitude. Because of that we got the original number. Likewise, here we have performed two opposite mathematical operation with same magnitude. That means square and square root means two opposite mathematical operations. Okay. So it will give the original number, that is x. Here also two mathematical operations, two opposite mathematical operations, square and square root. If we consider someone's square and its square root, it will give that someone. Okay. If we consider someone square root, square and square root, it will give the someone. That someone. Okay. It will give that someone. So if you consider square and its square root, it will give that original number. Okay. So likewise we can find the remaining length. Okay. Remaining length of that side. Likewise, if you have two lengths, it shouldn't be this and this, it can be this and this, and you have to find this side, and it can be this and this, and you have to find this side. Either way, you can find a length of a triangle, right angle triangle, by using this Pythagoras theorem. This is the Pythagoras theorem. By using Pythagoras theorem, we solve that one. That is the length of this hypotenuse. Okay, length of this side. That is the Pythagoras theorem. But we didn't still come to our lesson today. So please take this to our book and we can move to the lesson. So today lesson is motion in a straight line. What is straight line? We call this is a straight line. We call this is curve lines. So we talk about motion. Motion චලනයක් මොන හරි ගමන් කිරීමක් in a straight line. මේ වගේ චලිතයක් මොන හරි දෙයක් මේ විදිහට යනවා නම් මෙහෙම නෙවෙයි. කෙලින් යනවා නම්. Okay. So in this lesson we talk about motion in straight lines. Okay, motion in straight lines. Actually in this lesson we discuss a lot of quantities like speed, velocity, acceleration, deceleration, distance, displacement, okay, gravitational acceleration. Those are the quantities we are going to discuss in this lesson. Okay, so we call this those are quantities. Okay, so first two quantities we are going to discuss is what? Distance and displacement. Distance and displacement. Okay, so we are going to discuss what is the difference between those two quantities and what is distance and what is displacement. Okay, let's see. As an example, this is our home. Okay, I have to go through this path to get to my nearest town. Let's say it is Kottawa. Okay, I have to travel 1000 meters. That means nearly 1 kilometer to reach to my nearest town. I have another path like this. But it takes 1500 meters. Okay, so I can go through this path. If I go through this path, I have to travel 1000 meters. If I go through this path, I have to travel 1500 meters. Okay, if I join these two places with a straight line, it is the shortest distance between these two places. It is the shortest distance between two places. Let's say it is around 700 meters. Okay, so in this part I have to travel 1000 meters. In this 1500. Here it is 700 meters. So you can clearly see that this is the shortest distance between these 2 points. So there is a speciality in this distance. This is also distance. අපිට ගමන් කරන්න යන තියෙන යම්කිසි දුරක් තමයි distance කියලා කියන්නේ. දුරකට අපිට ගෙවාගෙන යන්න තියෙන මීටර ප්‍රමාණය. How much meters we have to travel, that is distance. කොච්චර ප්‍රමාණයක් අපි යන්න ඕනද? Here is also distance. Here is also distance, but it is the shortest distance between these two points. So this has a specialty because it is the shortest distance. Because of that, we call that displacement. So displacement is the shortest distance between 2 points. Or in a better way, we can call the straight line distance between 2 points. It is the better way. Straight line distance between two places is called displacement. Other parts we can call distance, which is not formed by a straight line, So this is not formed by a straight line, this is not formed by a straight line. So we can call those things call those paths the distance. What about this one? This has straight lines, this has straight lines, so this is displacement or distance. Definitely this is distance. Okay, I told you, if I connect these two places with a one straight line, that is the displacement, not with the two straight lines. This is also comes under what? Distance. This is distance, this is distance, this is distance. If I join these two places with the one straight line, that distance is the displacement. Okay, so you have to know the straight line distance between two places is the displacement. Other parts comes under distance. So this is the difference between distance and the displacement. Okay. So I told you there are several quantities in this lesson, as distance, displacement, speed, velocity, acceleration, deceleration. So those quantities can be categorized into two types. What are the types? Scalar quantity and vector quantity. Scalar quantity and vector quantity. What is scalar quantity? It has a magnitude. But it does not have a direction. Actually, does not have a direction means scalar quantities does not depend on direction. Okay, direction cannot make a change to scalar quantities. In other words, there is no meaning in defining direction to scalar quantities. In other words, there is no specific direction to scalar quantities. Okay, there is no direction means this one. Okay? It has a direction, but there is no specific direction, and we can call it does not depend on direction. Okay, you have to keep it in that way. It does not depend on direction. There is no meaning in defining direction for scalar quantities. That is the meaning of it doesn't have a direction. Okay, it has a direction, but we call it does not have a direction because scalar quantity does not depend on direction. Okay, vector quantity, those have magnitude, like scalar quantities. It has a magnitude and also it has a direction. Okay, I know that you did not understand this very well. So let's see an example. Let's examine an example. Okay, what is the example? Scalar quantity. Distance is a scalar quantity. Distance කියන්නේ scalar quantity එක. What about displacement? Displacement is a vector quantity. Okay, let's see how those quantities behave as scalar quantity and vector quantity. First, I would like to take distance, which is a scalar quantity. That means it has a magnitude, but it does not have a specific direction. Okay, you better get that word. It does not have a specific direction. Okay, let's see. Scalar quantity, that means distance. So I know this is the distance. This is a distance. But this is displacement. Let's choose one distance. I choose this path. Okay, I choose this path. Let's say we have 300 meters to this point, and we have 400 meters from this to this, and we have 200 meters from this to this point, and we have 100 meters from this point to this point. Okay, if you can note, first I should travel in this direction, and then I should turn my vehicle into this direction. See, this direction, and I have to travel afterwards this direction here, this direction, and again I have to travel this direction. Okay, can you notice in distance I have traveled this direction, this direction, this direction, this direction. But although I have traveled several directions, what is the magnitude of this complete path? 300 plus, 400 plus, 200 plus, 100. Have I ever considered the direction I have traveled in calculating the total distance? No. Why? I have calculated 300, I have added 300 to this 400, but 300 is to this direction, 400 is to this direction. But I haven't considered the direction. I just take this and add to this number. Then I have traveled this direction, but I haven't considered the direction. I just add these total figures to this number. And then I have changed my direction, but I haven't considered that. I just add this 100 to previous figure. That is how I came with 1000 meters. I haven't considered the direction, and I don't want the direction actually. I just want to sum up all these values together. It does not depend on the direction I have traveled. What I want to do is I just wanted to add this figure to this figure, this figure to this figure, and this figure to this figure. So for that, I don't want the direction actually. So that is why I told you that direction cannot change anything to scalar quantity, to distance actually in this scenario. This direction does not make any change to the distance. Whatever the area, whatever the direction I travel, they don't consider it. They just add those figures together. So distance does not depend on the direction. මම මෙහෙම කොහෙට ගියත් උට අදාළත්වයක් නැහැ. ඌ කරන්නේ මේ සෙට් එක එකතු කරන එක. උට අදාළ නැහැ කොහෙට ගියත්. මෙහාට ගියාද මෙහාට ගියාද මෙහාට ගියාද මෙහාට ගියාද උට ඒක අදාළ නැහැ. ඌ කරන්නේ මේ ටික එකතු කරගෙන යන එක. එතකොට මෙන්න මේ කොහෙට ගියාද කියන එක උට අදාළ නැති හින්දා we call that scalar quantity does not depend on direction. In other words, it does not have a specific direction. Specific direction එකක් නැහැ. ඕන පැත්තකට යන්න පුළුවන්. කොයි පැත්තට ගියත් අපි කරන්නේ මොකද? එකතු කරන එක. අපිට අදාළ නැහැ කොයි පැත්තට මූ ගියත් අපි කරන්නේ මොකද? මේ ටික එකතු කරන එක. හරි. ඒක මං කියන්නේ දිශාව අපිට අදාළව නැහැ. දැන් මූ මෙහෙට 300ක් යන්නේ නැතුව අරහෙට 300ක් ගිහිල්ලා මේ ටික ආවා. අපි 1000යි කියලා කියන්නේ. අපිට අදාළ නැහැ මූ කොහෙට ගියද කියලා. අන්තිමට මූ කොච්චර මීටර් ප්‍රමාණයක් ගෙවාගෙන ආවිල්ලා දිනවද කියන එක විතරයි දුර කියන එකට වැදගත් වෙන්නේ. කොයි පැත්තට ගියාද කියලා දුරට වැදගත් නැහැ. ඌ බලන්නේවත් නැහැ ඒක මේ මෙහෙට ගිහිල්ලා ඌ ඒව ගණන් ගන්න නැහැ නිකන් එකතු කරගෙන යනවා. That is why I told you scalar quantity does not depend on direction. What about the vector quantity? Displacement is a vector quantity. Let's see. This vector quantity has a specific direction here. specific direction. Specific direction. It has a specific direction. What about the magnitude? Vector quantity, that is a displacement, has a magnitude 700 meters. That is the magnitude. Okay. What about scalar quantity? Scalar quantity means here distance. In this distance we have a magnitude 1000 meters. So both this scalar quantity and vector quantity has a magnitude, but this one only has the direction. This does not. Okay. So that is the difference between scalar quantity and vector quantities, and that is the difference between displacement and distance. So it's better to take a sketch of this one, and we can move to the next area. Okay. Let's consider a path with the shape of a rectangle. This is A, this is B, this is C, and this is D. A person has traveled from A to B. Start point is A, from A to B, then B to C, C to D, and then again D to A. So end is A also. This is 5 meters. As this is a rectangle, this side is also 5 meters. This is 10 meters, and because of that, this is also 10 meters. Okay. So a person has traveled from A to B, then C, then D to A. Okay. It asks what is the distance of this person and what is the displacement of this person. Let's find. Okay. So you know what is the distance. 5, 10 means 15, and again 5, 10 means 15, 15, 15, 30. Okay, let's see. From A to B, he has traveled 5 meters upward direction. And from B to C, he has traveled 10 meters to this direction. And from C to D, he has traveled 5 meters downward direction. And from D to A, he has traveled 10 meters from this direction to this direction. I told you distance is a scalar quantity, which means it does not depend on the direction. So it does not depend on the direction. මේ කොහේ පැති වලට ගිහිලා තිබ්බත් උට අදාළ නැහැ. උට පුළුවන් මොකද්ද? මේ ටික එකතු කරගෙන යන්න. මේ පැත්ත අදාළ නැහැ උට. 10 15 10 15 30. 30 meters. Let's find out the displacement. Before I calculate displacement, I can take the calculate the displacement in my mind. Okay, anyone can do that because very simple that one. So I told you what is displacement. Displacement is the straight line distance between 2 points. Otherwise, in other words, it can describe as this. In the tute it is given. Furthermore, it can be identified as a, that means displacement. Okay, displacement can be identified as a change of position that occurs from one point to another point in the particular direction. Change of position that occurs from one point to another. That means change of position. change of position. Let's say those 2 points are in the same points and we change the position. Okay, that shortest distance between 2 points. Okay, otherwise the shortest distance between these two points is called what? Displacement. Otherwise, the change of change of position is called displacement. Okay, so in that way we can also describe what is displacement. Here, what are the two positions? Those are the original position and the end position. So please keep it in your mind. If you are asked to calculate the distance, first thing you have to analyze is what is the motion it is considered. What is the motion that I have to consider? So in this one, I told you find the displacement. That means what is the motion? This person has traveled this way, this way, this way and this way. So that is the complete motion you have to consider. Okay. So in that motion, what is the original position? A. What is the end position? It is also A, because he has already come to A position. Because of that, original pace is A and the end position is also A. Because of that, there is no straight line distance between two positions, because those two positions are the same position. Okay, because of that, they do not have a straight line distance. Okay, because those 2 points are the same position. So because of that, displacement is 0. Okay, you can calculate it from your mind. Calculate it in your mind. So that is the answer, but we can calculate it. How? Let's see. For that, we have to consider part by part. Okay. Before that, if I ask you this one, please consider the motion from B to C. A to B. Please consider the motion only from A to B. Okay. I have told you, if you were asked to calculate the displacement, what is the first thing you have to do? First thing you have to do is consider the motion. Which motion I have to consider? So which is the motion? From A to B. First one is done. From A to B. In that considered motion part, what is the start position and the end position? Start position is A. End position is B here. Why? Because we only consider from A to B. Although he has traveled from A to B, B to C, C to D, D to A, I only consider from A to B. Because of that, start position is A and end position is B. Okay, so what is the distance? It is 5 meters. Distance 5 meters. So what is the displacement? Displacement is the straight line distance between start and end position. Start is A, end is B. What is the straight line distance? It is also 5 meters. Displacement 5 meters. Then I ask you to consider from A to C. A to C. Okay, what is the distance? From A to B it is 5, B to C it is 10. Because of that, 5 plus 10, that is 15 meters. That is 15 meters. Okay. What is the displacement? So now you know the theory. First you have to consider the motion. Which motion part you have to consider? From A to C. From A to C, what is the start position? It is A. What is the end position? It is C. This is the start position. This is the end position. So what is the displacement? Straight line between end position, start position and the end position. Straight line between start position and end position is this one. එහෙනම් මෙන්න මේක තමයි මොකද්ද? start position එකයි end position එකයි අතර තියෙන straight line එක. එහෙනම් මේක තමයි displacement එක. So if you calculate this length, if you can calculate this length, this is the displacement. You can calculate it because this is a right angle. So this become a right angle triangle. In that right angle triangle, you know two sides. You do not know only one side. Because of that, you can apply what? Pythagoras theorem to this triangle and then find x. This is the displacement for A to C. Okay. Now I want the total displacement. If you consider the total motion, what is the displacement? For that I have to consider from A to B, B to C, C to D, D to A. That is the total motion. When I am considering the total motion, I can divide the total motion into 4 parts. That means from A to B, B to C, C to D, D to A. Okay. From A to B part, what is the displacement? 5 meters upward direction. From A to B, upward 5. From B to C part, what is the displacement? It is 10 meters for this direction. Why? If I consider only B to C, start position is B, end position is C. Because of that, straight line between start point and this end point is this one. That is 10 meters. Likewise, if I consider only C to D part, my displacement is 5 meters downwards. If I consider A to D part only, what is the displacement? 10 meters from to this direction. Why? If I consider only A to D, D is the start position and A is the end position, because he has traveled like this, like this. Because of that, if I consider only A to D, his start position will be D, his end position will be A. Straight line between these two is 10 meters. What is the direction? This one. Because he has traveled like this. That is why the direction is this. Okay. Now, you know displacement is a vector quantity. Displacement is a vector quantity. Because of that, we have to consider magnitude and also direction. Why? Displacement is a vector quantity and vector quantities has both magnitude and direction. So when calculating or when we perform any mathematical operation on vector quantities, we have to consider magnitude and direction. Both we have to consider. Okay. not only magnitude. So here this is direction, this is here, here, here. So we have to consider the direction. In previous time we didn't actually consider the direction. We just sum up all the values. We didn't consider the direction. කොහේ පැත්තට ගියත් අපිට දාන්නේ අපි එකතු කරලා දැම්මා. ඒ කියන්නේ අපි consider කරලා නැහැ direction එක. But here as this is a vector quantity we have to consider the direction. How we consider the direction? Let's see. This is how we consider the direction. If I consider upwards as positive, I have to consider downwards, which is the opposite of upward, as minus. If I consider upward as positive, I have to consider downwards as negative. Why? Because the opposite of upward is downwards and opposite of plus is minus. If I consider this direction as positive, I have to consider this direction as negative. So this plus 5 meters is cancelled by this minus 5 meters. This plus 10 meters is cancelled by this minus 10 meters, that is 0 meters. So displacement is 0. Here plus 5 is cancelled by minus 5, but here plus 5 is not cancelled by sorry, let's see like this. This upward 5 meters is cancelled by downward 5 meters, but here that upward 5 meters is not cancelled by this downward 5 meters. Why? We haven't considered the direction here. Because of that, this is also plus, this is also plus. That means it is 10 meters. If we calculate this 5 and this 5, it is 10 meters. But here it is 0. Because here we have considered the direction. Here we haven't considered the direction. That is why this upward 5 meters is also 5 and this is downward 5 meters is also plus. I think I missed the plus here. If I repeat that one, we haven't considered the direction in distance because it's a scalar quantity. That is why this upward 5 meters is plus and also this downward 5 meters is also plus, because we haven't considered the direction. Why? Because distance is a scalar quantity. Scalar quantities does not depend on the direction. Here displacement is a vector quantity. Because of that we have to consider the direction. That is why upward is plus and downward is minus. Okay. So take a quick sketch of this one. I will erase now. Pause the video and take the sketch. Now I am going to give you how we give the direction properly. Up to now I have told this direction, this direction, this direction, this direction. So it is not the proper way to express it. Okay. So there is a position A and another location here B. Okay. So straight line distance between two places is 10 meters. That means the displacement is 10 meters. Here the north, here the east. We have 5 degree angle here. Okay. It is given under 1.3 in your tube. Magnitude and the direction of the displacement. Okay. We can say displacement from A to B is 10 meters 50 degree from north to east. Displacement from A to B is 10 meters 50 degree from north to east. උතුරේ සිට නැගෙනහිරට කැරගෙනකොටනේ මේක එන්නේ 50ක්. So we can say from north to east it is 50 degree. Likewise we can express the direction and the magnitude of the displacement or the position. So here it is very useful. Distance is displacement is very useful. Why? දැන් හිතන්නකෝ අපි displacement එකෙන් නැතුව distance එකෙන් කිව්වා කියලා තනක්. ඊයෝ මෙතෙන්ට යන්න මෙහෙම මාර්ගයක් තියෙනවා. ඒක මීටර් 20යි. හරි මේක ඇවිල්ලා මොකද්ද? දුරක්නේ. මේක තමයි displacement එක කියන්නේ. මේක ඇවිල්ලා distance එකක්. කවුරු හරි කිව්වොත් උතුරේ සිට නැගෙනහිරට යනකොට මේ අංශක 50ක් කැරකෙනකොට මීටර් 20ක් දුරින් නම් ඉන්නේ B. කවුරු හරි ඔක පරිලලා වෙන තැනකට යන්නත් පුළුවන්. How? Let's say there is another path and there's a position in this line and that path distance is also 20 meters. දැන් මෙන්න මේ ලක්ෂය තියෙන තැන දුරෙන් කිව්වත් අපිට 8 කියන්න පුළුවන්නේ උතුරේ සිට නැගෙනහිරට අංශක 50ක් කැරකෙනකොට මීටර් 20ක දුරෙන්. මේ ලක්ෂය කියන්න පුළුවන් එහෙම. උතුරේ සිට නැගෙනහිරට අංශක 50ක් කැරකෙනකොට මීටර් 20ක් දුරෙන්. එතකොට දුරෙන් එකම විදිහට කියන ලක්ෂ ඕන් තරම් තියෙනවා. මෙතන ලක්ෂ දෙකක් තියෙනවා. එතකොට distance එකෙන් මොන හරි කිව්වොත් දුරෙන් මොන හරි කිව්වොත් අපිට හරියට මෙතන හොයාගන්න බෑ. That is why distance comes to play. Sorry, displacement comes to play. And displacement is very useful when we are referring a position. තියෙන තැනක් කියනකොට. හරි. Then why distance is there? Distance කියන එක වැදගත් වෙන්නේ එක වෙලාවකට displacement වැදගත් වෙන්නේ වෙන දේවල් වලට. Let's see, we have here a three-wheeler and we come to this place from this place. දැන් අපිට කියන්න පුළුවන් three wheel එකෙන් බහලා අපේ මේ විස්ථාපනයේ අයියේ මෙච්චරයි මම විස්ථාපනයට ගෙවන්නම් කියලා. ගිහිල්ලා දා හිටපු දැන්ට මාප්පු. එහෙම යන්නේ ඇයි? එයාගේ පෙට්‍රල් ටික නාස්ති වෙන්නේ. මේ පාරෙන් එන්න. ඒක දුරයි. ඒකට එයයි ඒකෙන් හින්දා එයා මේ පාරෙන් එන්න ගන්න කියන්නේ. ඒකට එයාගේ ටයිම් කියන්නේ මේ පාරෙන් එන්නේ. නැතුව ඩිස්ප්ලේස්මන්ට් එක නෙවෙයි එයාගේ ටයිම් කියන්නේ. මේ පාරෙන් තමයි ටයිම් එක සහ එයාගේ පෙට්‍රල් වැය වෙන්නේ. ඉතින් ඒ හින්දා දුර කියන එකට අනුව තමයි මොකද්ද? යම් කිසි ප්‍රවාහන ගාස්තු වගේ දේවල් නිර්මාණය කරලා තියෙනවා. ට්‍රාන්ස්පෝර්ට් ෆී එක වගේ. නැත්තම් අපිට නම් වාසි අර ඒක ට්‍රැවල් කරන ඒ වාහනේ එළවන පුද්ගලයාට හරි අවශ්‍යයක් වෙනවා ඩිස්ප්ලේස්මන්ට් එකට ගත්තොත්. මෙතන ඩිස්ටන්ස් එකට තැනක් කිව්වොත් එහෙම තැන් ගොඩාක් තියෙන්න පුළුවන්. හරි තැන නිශ්චිතව ප්‍රකාශ කරන්න බෑ distance එකේ. So in here we need displacement, in here we need distance. Okay. So I covered all the required details you have to know regarding displacement and distance. Let's see, let's solve some problems, or let's do some exercises also. Okay. So the first exercise is students has traveled like this. This is A position. This is B. He has traveled like this. Okay. So in our exercise 1, it is given some details. Okay. It is said this is 6 meters, this is 8 meters, this is 4 meters, and this is 3 meters. Okay, now it asks, what is the distance that the students has traveled, and what is the displacement? What is the displacement? So you can easily calculate the distance. 6 plus 8 plus 4 plus 3. අපිට පැත්ත වැඩක් නැහැ කිය. ඩිරෙක්ෂන් එක වැඩක් නැහැ. තියෙන සම්පූර්ණම ගෙවාගෙන ආපු මීටර් ප්‍රමාණය එකතු කරා නම් හරි. 8 6 14 4 18 3 21. 21 meters. What is the displacement? Now I have told you the theory to calculate the displacement. First, you have to consider the motion. What is the motion? From this to this. From this to this. Okay. From that motion, if we consider that motion from A to B, what is the start and end position? Start position is this, end position is this. Then what is the displacement? Straight line distance between these two positions. So this is the straight line. It is also given in your exercise. So you have to calculate the length from this to this. In other words, of this straight line. The distance of this straight line is the answer. You can easily calculate this length. Let's see, it is x. And also you can easily calculate this length. Let's say it is y. So displacement is this total length, that means x plus y. X plus y. Let's find x and y. So actually this is a right angle. This is a right angle. Because of that, this is a right angle triangle. You can use Pythagoras theorem to find x. This x is the hypotenuse. So we can say x square equal to this side square, that means 3 square, plus this side square, 4 square. So that is how we apply the Pythagoras theorem to this triangle. දැන් මේක Pythagoras theorem එක දන්නේ නැත්නම් කවුරු හරි වීඩියෝ එකේ මුලට ගිහිල්ලා බලන්න ඒක කියලා දුන්නා. මුලටම. Okay, x square equal 3 square means 9, 4 square means 16, then x square means 25. Okay, then x square equal to 25 means 5 square. 5 square. Then you can consider square root to both sides. I told you, if you consider someone square and its square root, it results that someone. If you consider someone's square and its square root, it results that someone. Okay. Likewise, you can find y. Why? Because this is a right angle. Because of that, this is a triangle. Okay, you can apply the Pythagoras theorem. This is hypotenuse. Okay. Y square, by applying the Pythagoras theorem, we can say y square equal this 8 square plus this 6 square. Y square equal 8 square means 64. Say 6 square means 36. That means y square equal to 100. 64 plus 36 means 100. Then y square equal 100 means 10 square. 10 වර්ගය තමයි 100 කියන්නේ. 10 වැඩි කිරීම 10 නේ 100 කියන්නේ. 10 වැඩි කිරීම 10 කියන්නේ 10 square. Then you can apply square root. I have told you, if you consider someone is square and it is square root, it results that someone is square and it is square root, that results someone. Okay, so x is 5, y is 10. Because of that, answer is displacement is x plus y. That means 5 plus 10, it is 15 meters. That is the displacement. Okay, that is the displacement of what? This student. Okay, so take this to your book, then we can move to the next exercise. Okay, next exercise, it is set A, this is B, this is C, this is D. This is 10 meters from A to B, 20 meters from B to C, and 30 meters from C to D. What is the exercise? If a person travels from A to D, and again comes to C, what is the distance and displacement? What is the distance? You have to add 10 meters plus 20 meters plus 30 meters. All the directions are from this to this. And again he has come from D to C. That means again 30 meters. What is the direction? The opposite direction. But in distance, you don't want to consider the direction. You have to only sum up the values. That is 30, 90 meters. What is the displacement? He has traveled from this to this direction 10 meters, to this direction from D to C 10 meters, from C to D 30 meters. Okay, අර theory එකට මේ ගන්නේ C to D consider කරනකොට start position එක C, end position එක D. ඒ දෙක අතර straight line එකේ දුර 30යි. පැත්තකට මෙහෙට. Then D to A. If you consider D to A, what is the start position? D. End position? C. What is the straight line distance between two position? 30. What is the direction? D to C. Because he has again come to C from D. Because of that, direction is this one. Okay. If you consider this direction as plus, you have to consider this direction as minus. Okay, that will cancel this and this. What is the answer? 10 plus 20 is 30. You can put plus here also plus. Why? Direction is same. If you consider this direction, it is plus, this direction plus, this direction plus, this direction minus. Okay, so that is how we can calculate the displacement. There's another method, not another method. Actually, see what is the total motion. I have considered by part here. කොටසින් කොටස තමයි consider කරලා තියෙන්නේ. එහෙම නැත්නම් අපිට පුළුවන් whole motion එක, total motion එක, complete motion එක consider කරන්න. What is the complete motion? He has travelled from A to B to C to D to then from D to C. What is the end position? Here. What is the start position? Here. So it is very easy. What is the straight line distance between start position and end? It is 30 meters. Start position is here, end position is here, then direction is that way. Because start is here, end is here, because of that direction is here. මේ පැත්තට තමයි උ ගිහිල්ලා තියෙන්නේ. Because of that direction is this one. Okay? එතකොට මේකේ පැත්ත කොහොමද දාගන්නේ? ඒක පැත්ත උන් දාගන්න පුළුවන්. අපි දන්නවා ධන 10 ධන 20 එකතු කරාම ධන 30යි. අපි ධන විදිහට සැලකුවේ කොයි පැත්තටද? මේ පැත්තට. මේ පැත්තට. එහෙනම් මෙයා ඔය ධන 30ක් නැවිලා තියෙන්නේ. ධනයි කියන්නේ අර පැත්තට. So that is how we can calculate distance and displacement. Okay? Distance and displacement. You have homework. In this question there is another one. If a person travels from A to C and again comes to B, from A to C and again comes to B, what is the distance and displacement? So you have to answer that question. You have to calculate the distance and displacement. So with that, take this to your book. With that, our today lesson is completed. That is distance and displacement. I think I have given you all the required theory knowledge of distance and displacement. So we can meet with what velocity and speed in the next video.